So for this first one, I started to solve the triangle. And I knew I had to use law of sines because, again, it was not side angle side. So I knew there could be two possible triangles. And when I searched for the first angle in question, I found out that it would be 22.34. So I also subtracted that from 180 and got 157.66. I said, is 22.34 plus 17 the angle already given under 180? Yes, so I had to use that for one triangle. And then I said, okay, is 157.66 plus 17 under 180? And yes, that was. So I also had to create two triangles. And you'll see above is one triangle, over here is the other triangle. And it did not do the area for this one. However, you can look down below to see the area formula used. So when I set up this triangle, you see, because it is a triangle with one angle in between two sides, we know that we're using the area formula. So we know area is 1/2 of A times C times the sine of B. Now remember, whatever angle they give us, which they give us angle B, we know that we're going to be using the sine of that angle. So we're going to be using sine of B. Therefore, we know that the other two values that we multiply are the little letters, and we want to have all three. So since we already have B, we know we're going to have little a and little c, because then we have A, B, C. So that's one way to remember the formula. Then, when we go to plug in, we know area is 1/2 of one of the sides times the other side times the sine of angle B. Therefore, we get 787.01 square feet area, square feet. So for this next one, we can use law of sines again. We are given 140 distance between P and Q. We're given these two angles, and they want to find the distance from side P, side Q, or angle P, angle Q. So to this flagpole. So the flagpole is over here, right? Now if we know two of the angles, the third is 180 minus those two, giving us 52. And then we just use our ratios using law of sines to find our unknowns. So we could do little p over the sine of P is equal to side 140 over the sine of the angle across from it. Then we get P is 166.9 feet. Then the distance on the other side, Q length, we set up law of sine ratio, and we get Q is 150.6 feet. For this next one, for number 2, it says that someone at an observation tower sights a fire that's 39 east of north. So you first look straight ahead north, and then you swing to the right east, so that gets you this 39 degrees. Then you always want to create right 90 degree angles. So 90 minus 39 gets you that 51, the inside of your triangle. So then it says Ranger B is 10 miles to the west of A. So west is to the right of A. So we know that that's 10. And then it also says that it sights the fire at 42 west of north. So when you're looking up straight and then you swing to the left for west, you get 42. If you subtract that from 90, the inside angle is 48. Once you know the two inside angles, you know that the last angle is 180 minus the two inside angles, getting you 81 degrees. Once you get that far, you can use law of sines to set up ratios and our proportions to solve for little a and little b. And there you go. So the next one, you have to pay attention to the wording. So it says that there's two streets. So here's a street, here's a street. They form an 85.9 degree angle. It says that it's an isosceles triangle and that each street is 150 feet long. So you know they're the same. Because you have side, angle, side, you know you're using law of cosines. So when you look at your formula sheet, because you are trying to find another side, little b, then we use the formula b squared equals a squared plus c squared minus 2ac times cos of b. So we're going to isolate, take square root, find little b. When you plug in all the values, you end up with b is 204.4 feet. So the next one says a plane leaves A and it heads to B and it covers 85 miles due north. It says the plane first goes 20 miles heading towards B, but then it has to take a slight shift northeast 10 degrees. It then travels another 20 miles in that direction. It then heads back towards B. So we know that this guy's 65 because if it starts going 20 and the length from A to B is 85, the little part's 20, then the remainder is 65. Then if they swing and there's a 10-degree angle here and we know it travels for 20 miles, we have the 20, we have the 65, we have the 10 degrees. Therefore, we can find x, the distance that it traveled from its new point to dot B. Then when you plug in using law of cosine's formula, you end up solving and finding out that the side that we want, x, is 45.44 miles.